Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, we're coming off 3 weeks where we were programming in IEC. We're going to take a little different direction now. Here's our topic for today. We've got new OCS-I modules to talk about. So we are fully switching over from programming and software over to hardware. And the hardware we're talking about today is a couple new I/O modules for our OCS-I family of expansion and remote I/O. So without further ado, let's just dive right into it and take a look at how we are breaking down today's topic. Okay, we're going to start with a quick review of OCS-I because I was looking and it's been a while since we really covered OCS-I in any detail here on the channel. Of course, our primary goal today is to tell you about these new OCS-I digital I/O modules that are now available. We'll talk about what are the requirements from a Cscape and firmware standpoint so you can take advantage of these new options. And then we're going to cover a couple of things, again, that we haven't covered in a while. We're going to go through assembly of OCS-I that I don't think we've really ever covered here in the channel, and we're going to revisit OCS-I configuration in Cscape. All right, here we go. Okay, so what is OCS-I? Well, it is a family of remote and expansion I/O that works really well with just about any Horner controller. Now, when we say remote I/O, we're usually talking about I/O that's located, maybe even a few hundred feet away, or maybe even a few hundred meters away from your main controller. And when we say expansion I/O, that's usually just I/O that's, maybe in the same control panel, but it's above and beyond what's built into your OCS controller. Now, OCS-I is a ground-up design. Now, we didn't design the mechanical package. We took advantage of an awesome package from Phoenix Contact, so the plastic and the terminal blocks, we didn't design those, but all the circuit boards, all the firmware, all the configuration, it was a complete ground-up design, and it was really integrated fully into Cscape and the OCS. Now, where OCS-I fits in your application, really it could fit in a lot of different places, and it really doesn't matter which of the Horner OCS controllers you're using. Whether you're more on the low end with the Micro OCS, whether you're using the Prime series, whether you need just a little bit of I/O in the same panel or a lot of I/O remotely, it really doesn't matter. Whatever you're doing, if you need some extra I/O, OCS-I can be a great fit. And if you happen to have one of those applications which needs a lot of I/O, the density of OCS-I, especially with these two new I/O modules we're going to talk about today, those are a real advantage. And yes, about a year and a half in from launch, certainly OCS-I is quickly becoming our primary I/O offering. Now, as with a lot of expansion I/O platforms from a lot of different automation manufacturers, OCS-I starts with an I/O base. So that is the building block you have to start with before you can start adding additional I/O. And if we take a look at the CNX I/O base, which is what we offer today, the CNX 116, of course, you have LED status information to let you know, is the network okay? Is the base okay? From a connectivity standpoint, we use RJ45 style modular patch cables, say that 5 times fast. However, it's not Ethernet based, okay? It's CAN based, but we still use the modular cables to make it easy. And then on the back plane, there's a special connector designed by Phoenix that allows you to join up to 8 modules total, including the base. And the way that connector is designed, if you ever need to replace a module in the middle of the stack, you don't have to completely disassemble everything. You can just take the module out of the middle very easily and replace it. So it's a really nice design. Now, one of the unique capabilities of the CNX 116 base, which is the one we're currently offering, is that it offers some really innovative I/O built right in. So you've got 6 I/O points, 2 of which are flexible digital or analog, 2 of them are high capacity DC outputs, and then you've got a high resolution analog in and a really nice flexible analog out as well. So when you start with the CNX 116 base, you're not starting from 0. You're starting with a nice little bit of complement of some accessory I/O there. All right, now, again, one of the things I will stress is that support for larger I/O systems is something that OCS-I does well. It does well with small systems. It also does well with big systems. And since we're adding these new higher density modules, that's going to make it even better in those applications. Remember, with OCS-I, you can have a total of 8 modules per base and up to 16 bases per system. So you can have a very large system in total if that's what you need. If you don't need a lot, you don't need to buy a lot. Now, the original module lineup that's been available for 15 or 18 months or so is shown here on the screen. 8 in, 8 out, DC, 4 in, 4 out with relays, some high current relay outputs, even AC inputs. So if you're doing any retrofits, you don't necessarily have to switch everything over to 24 volts if it doesn't make sense. We've got a tremendous 4-channel analog input card that is high resolution, where every channel is configurable between voltage, current, thermocouple, and RTD. And then we have a very flexible analog output card, which even supports minus 10 volt to plus 10 volt, in addition to the 0 to 10 and the 4 to 20. So the existing lineup is quite strong. All right, now let's talk about the new modules that are available, both of which are higher density digital modules. Okay, we've got a 16-point DC input module and a 16-point DC output module. Now, with these modules, ultimately, you're going to be able to have as many as 128 inputs or 128 outputs in a single rack if that's what your requirements would be. Of course, you can mix and match all you need. Now today, of course, because of the fact that our current I/O base, the one that we're offering today, has some I/O built into it already, you can only add 7 of these modules today to an existing system. But we'll be launching later in the year an additional base which doesn't have any built-in I/O. And with that one, you'll be able to get a full 128 inputs or 128 outputs using these new modules. Another thing to make a note of, and that is from a temperature specification, these new modules have extended temperature specs all the way down to minus 40. And on the top end, they'll support plus 60 C, which is 140 Fahrenheit. And then, of course, they support even wider ranges than that when it comes to storage temperatures. All right, now let's go into more detail on the 16-point DC input module. Now, all 16 inputs can be configured either as negative logic, that would be considered sourcing, or positive logic, that would be considered syncing. Now, I know what a lot of you are thinking, now wait, you just got it reversed. No, when you're talking about input modules, negative logic is sourcing and positive logic is syncing. When you're talking about the sensors themselves, of course, that's different. PNP sensors, which you use with positive logic inputs on your PLC side of things, and of course, NPN sensors, which you would use on negative logic PLC style input. So on this particular module, it will support both, but you have to select all or nothing. So they're all positive or they're all negative. Now, all inputs share the same common. And in addition to the 16 input terminals, you've also got 8 0-volt or common terminals there for your convenience. And of course, there's a full bunch of LEDs there, 1 per input. And then of course, a power LED and an OK LED as well. Okay, as we take a look at the wiring on the screen there, you can see just what I've described earlier, and that is 16 input terminals as well as 8 0-volt terminals that are there for your convenience. Okay, now let's turn our attention to our 16-point DC output card, where each of the outputs can drive loads as large as half an amp. And there's plenty of margin there as well. So these are some really good quality output drivers we're using here. Now, these are positive logic only or sourcing outputs only, which is pretty typical, which means you're providing, of course, the plus lead to your load. Now, this particular module is divided into 2 circuits of 8 outputs each. So that means you've got a voltage pin for supplying voltage to the first 8 outputs. That's called V1. And you've got another voltage pin for supplying voltage to the other 8 outputs. That's called V2. Now, each of the outputs, all 16 of them, are short circuit protected. So if you do have a short circuit condition with a power cycle, you should be, back and running again, of course, assuming you've fixed your short circuit. And then again, some extra terminals there for convenience. You've got a couple of extra voltage input terminals, and you've got 4 extra common terminals, and the full slate of LEDs like we have with the input module. Wiring is as you would expect for a 16-point output card, positive logic with 2 groups. Now, one thing I'll mention on that particular diagram, you're looking at the screen there. It's showing you've got two V1 terminals. That's where you land the voltage to drive your first 8 outputs. And it's also showing two V2 terminals for landing your voltage for driving your second outputs. Now, you don't have to use both the V1s and both the V2s. If your loads are, modest and you're not going to exceed 4 amps as a total on any one group, then you can just use one of those V1 terminals if you choose. Just thought I would make a note of that. Okay, some additional details when it comes to wiring these guys. They all feature removable terminal blocks, and we'll show you how those work here in a minute. They're spring clamp based, which means they're really fast to wire. All positions are labeled, unlike the picture on the screen there, which is showing it blank, but every position is labeled on the actual module itself. From a wiring standpoint, these support wires in size from 16 to 24 gauge, and I would encourage you, don't be afraid of smaller gauge wire. 18 gauge works fantastic for the types of ampacities we're talking about here, and especially since, we're talking about wiring from the terminal to your field terminal strip. Don't make things too difficult by using big heavy wire when it's really not buying you anything. Another thing, if you decide to use ferrules, and you don't have to, but if you choose to use ferrules, then there'll be no tool required when you actually insert the wire. Of course, you'll still need a tool to remove it. And if you do use ferrules, I would highly recommend use ferrules that have a barrel length of 10 millimeters. Some ferrules have an 8 millimeter barrel length. Get the ones with 10 millimeter barrels. They just work so much better. Okay, now when it comes to connecting OCS-I to your controller, we need to take a look at what the controller has when it comes to a CAN port. So a lot of our products, including the XL series and the Prime series, they have what's called an open style connector for CAN. So that's that plug you see there in the lower left. And that particular plug is where you land your wiring, and it's also where you place your termination resistors for one end of the network, if the OCS is on the end, for terminating the CAN network. Now, you can either buy a cable from us that's got a modular connector on one side for the OCS-I and an open connector on the other, or you can build your own. Just take a modular cable, chop it off, and it only takes 3 conductors, and it's quite easy to do. So you can do it either way you prefer. So again, if you've got an OCS with an open style connector for CAN, those are your options. Now, if you've got an OCS with an RJ45 port for CAN, that's typically the red RJ45 port when it comes to the Micro OCS, then you can just use an RJ45 patch cable like you might use for Ethernet. But remember, it's CAN. So it's the red RJ45 connector, not the black one, that's serial ports, not the silver one, that's the Ethernet, but the red one for the CAN port. And I also highly recommend this as well. If the OCS-I is at the other end of the network, then it needs to be terminated. And we have this handy dandy RJ45 termination plug. So easy, just buy a few of those, pop one at the end of every network if the OCS-I is at the end, and it couldn't be easier. Okay, so what do you need in order to use these two new modules, this new 16-point DC input or this new 16-point DC output module? Well, you're going to need a newer version of Cscape, at least Service Pack 10 or later. You're going to need a CNX 116 IO base revision BF or later. Okay, an earlier revision absolutely will not work. And you're going to need to make sure that your OCS firmware is up to snuff. Okay, and I've got the different firmware revisions that are required at a minimum here on the screen. Next, I'm going to show a short video where we show you how to physically assemble OCS-I from the boxes that you receive when you place your order. So let's take a look at that now. Okay, let's go ahead and demonstrate the mechanical assembly of OCS-I. Okay, now when you receive OCS-I, all right, this is what it looks like. It's fully assembled in the box, and including the fact that the backplane connector is pre-installed. Now, you'll actually need to uninstall the backplane connector before you actually build up your base full of I/O on your DIN rail. So we're going to go ahead and just pull that off now. Just comes right off, no problem. All right, and then the first thing we're going to do is kind of pre-assemble our backplane. Now in my system here, I've got 3 modules that I'm going to be working with here as a total of 3 modules in my base. And I just snap them together like this. Now the way you know which side is which from a right side up standpoint is the plug here on the left. That is going to need to be facing the left. All right, so that is the proper orientation. All right, once we've pre-assembled our backplane connectors, then we can just snap them on the DIN rail. Okay, make sure they seat fully. All right, and then we start with our base. And then using the DIN rail, here's our base. And then using the DIN rail as a fulcrum, we assemble them on the base until they snap in like that. Then once you've got the first one, it's even easier to get the next two, or 3 or 4 or 6 or 7 or whatever your total is for your base. All right, and there you go. So quite easy to assemble. They're very rigid. Typically, you're going to have end stops on both sides. That's just kind of the normal installation practice. And there you go. That's the mechanical assembly. Now, some of you may be wondering, hey, I thought that this I/O system featured removable terminals, and if you're looking here, you can't really tell that they're removable. They truly are removable. Let me kind of show you how that works. So I just have a module loose in my hand here. All right, and the reason I'm doing this is I want to show you this feature here, as well as this feature here. All right, and when we're ejecting, what we're going to do is place our medium screwdriver through the orange tab, and we want to land it on that silver feature down here. Okay, all right, so let me do this on the installed modules. And then once you do that, then you just pull straight down, and it pops all the terminal blocks up in one fell swoop. So nice and easy. So the key is to have a screwdriver that's not the smallest in the world. You're going to want a screwdriver that's at least a medium one, so that you'll end up with an easy job of ejecting those terminals. Now, another nice thing about OCS-I/O is if you use ferrules, now not everybody uses ferrules, but if you use ferrules like I'm using here, all right, then you don't need a tool, all right, to insert your I/O wiring. So I'm just going to go ahead and push it in there. It's in nice and tight, and there was no tool required to put that wire in. Now, if I want to extract a wire, of course, then I'm going to need the appropriate size screwdriver. Here we have one here. All right, there you can see the size of that guy. It's probably about the largest one you'd want to use for ejecting wires. And then I'll demonstrate that for you here. All right, and once I get my screwdriver in the right spot, it comes right out. Okay, now one thing you'll notice about this is that these ferrules, or this ferrule that I'm using here, has a slightly longer barrel than what you'll find on some of them. This has a 10 millimeter long barrel. Now, it's not absolutely required, but it is easier to work with these 10 millimeter barrels when you're inserting and removing wires from OCS-I/O. So that's something I wanted to point out here in this little short video. Okay, so that's just a look at the mechanical installation and the mechanical properties of the OCS-I/O system. Okay, so hopefully you got something out of that video as you take a look at how you can assemble everything. Now, next we're going to replay a video that I actually created probably 15 months ago for showing you how to configure OCS-I/O. And we really haven't covered it recently on the channel. And as people are just starting to use the I/O platform now, I thought it would make a lot of sense to revisit it. So even though we're configuring a base and some modules are not necessarily the new modules, there's really no difference in the procedure whatsoever. All right, let's take a look. Here's our first bench setup. I have a OCS-I/O rack that I physically assembled here. I have it connected electrically to my OCS through CAN cable here. It's actually a modified patch cable, like I've shown before. All right, I have a terminating resistor installed on the second RJ port here on the OCS-I/O base, and the OCS-I/O base is not powered up yet. Let's go ahead and power it up. Okay, I'll plug it in here with the power. All right, you can see we have flashing lights as it powers up, and I wouldn't expect that to change because the program I have running here in my OCS doesn't have any OCS-I/O configuration at all. Okay, I haven't gotten to that step yet. All right, I'm going to take a shortcut to the system menu that I've created here on my screen. Oh, that's not going to work though if I don't have the controller in run. So that just goes to show you that even the most experienced programmer can forget to put controllers back in run after they do their programming change. Okay, So now we're in run. So now I should be able to hit this button and actually go to the I/O menu in the system menu. That's a shortcut I created. I'll hit enter again to take a look at the OCS-I/O configuration, and there are no OCS-I/O bases configured, as I mentioned earlier. Okay, so we're starting from scratch, effectively. Physically assembled OCS-I/O, electrically connected, powered up, but no configuration at this point. Okay, now let's jump to Cscape, and let's go into the hardware configuration, and we need to go to our CAN tab where our OCS-I/O is physically installed. So I'll do that here now. Again, there is no OCS-I/O configuration or any other CAN remote I/O configuration right now. I'll hit the add button. I'll go to the OCS-I/O tab and select the CNX base. Now, I'm not going to hit OK here. I'm going to hit auto populate all. The reason this is going to work is because I am online with my OCS right now, and my OCS-I/O is powered up and physically connected to the OCS. So I'm going to hit the auto populate all button. Okay, it's asking me if I want to auto populate the I/O bases, letting me know if there was anything in here before, it's going to be overwritten. I wish to continue. Okay, we give it a few seconds, and it comes back and says, hey, here is an OCS-I/O base that I found with this UUID. And remember that UUID is a unique number, effectively almost like a serial number, but a unique number that is shipped with every single OCS-I/O base, CNX base, that we ship at Horner. So that's what it found. All right, it's asking me if I want to assign this net ID to its respective bases. The answer is yes, I do. Okay, so it is going out and checking out all the modules. It found them all, we think. It tells me the auto-populate is complete. All right, it says, hey, we've got a success with this UUID. And we say, okay. All right, and okay again. And there we go. We've got our OCS-I/O base, which is a base with 3 modules. If we take a quick look again at our bench, sure enough, that's what we have. But we're still not talking. As you can see, we still have flashing lights, plenty of flashing lights on the base. All right, so back to Cscape. All right, now this is kind of the automatic portion of the configuration that is now complete. The reason we can't do it all in one fell swoop is because there are some things we do have to manually tell the base in terms of how we want it configured. So we're going to start with the I/O base, and we're going to double click here. Okay, and we're going to give it a meaningful name to us. Now, base 1 is what it's called in automatic configuration or auto population. We could leave it like that, or we could just go ahead and give it a new name. So I'm going to do that now. I'm going to call this OCS-IO_1. That's what I want to call it. All right, network ID of 1 is perfectly fine. I'm going to assign a status register. Now, I've previously created a status register variable that I will assign here. Okay, it is 15 consecutive words. So I reference the first element of the array. And then here, from this point forward, I need to assign the digital in, digital out, analog in, and analog out real world I/O registers where I want all the OCS-I/O in this base to start. Okay, and in my case, I'm going to have them start at %I65, %Q65, %AI65, and %AQ65. I'm doing that because I know those particular addresses are well away from where the built-in I/O is mapped, so that's what I'm going to do. Now, because I'm using variable-based advanced ladder, I'm not going to type in %I65, for instance. No, I'm using variable-based advanced ladder, so I need to reference one of the variables built into the project. Now, by default, there is some real-world I/O arrays I can choose to take advantage of, and I'm going to do that here. So I'm going to use I64. Okay? Now, why 64? Well, remember, arrays are always 0-based. So %I65 references I64. Always the index is 1 less than the actual 1-based memory address. Okay, so I'm going to fill in the rest of these. And again, it's my choice is where I map these. I just want to make sure I put them in a location where they're not going to conflict with any other existing I/O. Okay, like the I/O that's built in, for instance. Okay, so I've got those populated the way I want them. I'm going to say, okay. Now, what else do I need to configure? Well, any of the I/O that isn't just digital I/O, I'm going to need to configure that. So let's go back to the base. I'll double click on the base. And this time I'll go to the onboard I/O tab. All right, and I'll go ahead and configure the onboard I/O the way I want it. So I'm just going to do this relatively quickly. For my universal analog in, I'm going to say I want that to be a 4 to 20 milliamp input with a range of 0 to 32,000, because after all, this is a 16-bit analog input. I'll assign a little bit of filtering for stability at the cost of a little bit of response time. I'll skip over alarm configuration at this point. On my two smart inputs, or we don't call them smart inputs, we call them flexible inputs. On our two flexible inputs, I will enable channel 1 and make it a digital input of 24 volts. And I'll enable channel 2 and I'll make it an analog input. And let's say I'm going to do it for 0 to 10 volts. Now this is a 12-bit analog in, but I'll still choose a range of 0 to 32,000. And then I'll go ahead and enable my analog output, let's say for 4 to 20 milliamps with a range of 0 to 32,000, because I always like to have the maximum resolution available, although this is a 12-bit analog out. So 0 to 4,000 would be just as good. And on the halt state, when that analog output is turned off, I want it to go to its minimum value. All right. And I'm happy with this configuration with my built-in I/O to my I/O base. All right. Now I've got a couple of digital I/O modules. Now generally there's almost nothing you have to configure with digital I/O unless, and I'll double click here, unless you want to go with negative logic inputs, because the default input filtering and not holding any outputs to last state is generally what we want. But if we do want to change to negative logic inputs, we would have to change that here. I'm not going to do that on either this module or the next one. Okay, so there's nothing really I need to change from the defaults here. On my ADU 100, I'll go ahead and set that up for thermocouple. Let's say J-type thermocouple on all 4 channels. All right, and I'll leave it at the default of degrees Celsius. Okay, now my update method, I want to update faster than every half second. Let's say I'm going to do it every, it's temperature, so it's probably not updating all that fast in real world. So I'm going to say 100 milliseconds. If I had some faster type processes going on here, I might set this to 25 milliseconds or something. But this is the frequency at which this module is going to be distributing new or broadcasting, if you will, new readings for these 4 channels. All right, and then again, we have our ability to use filtering, and I'll set it to a value of 3, again, to achieve some additional stability at the cost of a little bit of update rate. Okay, so there we go. That configuration, to my liking at least, is done. All right, so the next thing I'm going to do is I'm going to download this configuration to my OCS. All right. It's going to warn me that be careful, because I'm using Ethernet to communicate to the module, to the OCS. Be careful that you don't accidentally overwrite your IP address to the wrong value and lose communications halfway through, but that's not a problem in my case. All right, let's switch back to our overhead view now, or back to our benchtop view, and see what's happening. Well, look at that. We have all solids happening on our I/O base, so that looks like to be up and running. Now let's jump to the system menu on our OCS and see if we see anything for the OCS-I/O populated there. This is a shortcut I've created to get me to the I/O configuration screen. And if I hit enter one more time, it will take me to the OCS-I/O screen. And sure enough, look at that. It found the base. If I hit enter again, it will show me the populated modules along with the UUID that is sitting right there for the base that was populated. Okay, terrific. So that's all working. All right, so that is the really straightforward approach for configuring a single rack of OCS-I/O. Okay, so thanks for watching that again. I know that for some of you, it's been a while since you've taken a look at OCS-I/O, and I know it's been a while on this channel since we've talked about how to configure it. And I went through that pretty deliberately. It can happen really fast if you know what you're doing and you're not explaining to folks. Okay, so that's pretty much what I want to cover with you today from the standpoint of those new modules. And keep in mind, we've got plenty more OCS-IO product on the way for 2024. It's going to be a big year for OCS-IO. New I/O modules. We've got a new I/O base coming. We've got several new CPUs. It's going to be a big year in 2024 for OCS-IO. So stay tuned for sure. Okay, so this is where I remind you that we're here every Tuesday at 2 o'clock, whether we're fully live, whether we're fully pre-recorded, or like today, where I'm pretty much live, but I played back a couple of pre-recorded demo videos. We're always here ready to answer your questions, though, every Tuesday at 2 o'clock. So if you're watching live, give us those questions in the chat section. If you watch on replay, give us those comments in the comment section like Dario did. He had a question that he sent out that I was happy to answer this morning. So I grabbed a cup of coffee and I answered Dario's question, and hopefully I answered it to his satisfaction. If he has another follow-up, he can just post another comment or another question on the comment section. Okay. We have our OCS training schedule, as I mentioned, for the past few weeks. It's posted online. We've got a training class coming up next week. It's a basic training course, and Tim Brandt, I believe, is going to be teaching the course this upcoming week. So for those of you who've talked to Tim on the phone, but you've never met him in person, you'll get a chance to do that next week because Tim is teaching the course. Okay, so there are lots of ways to interact with us online here at Horner. You know, whether you're talking about our website or our YouTube channel, or you're active on LinkedIn, because we are. So we'd love to hear from you. We'd love to reach out and talk about your application. Okay, next week is going to be a little different. We're going to do something a little avant-garde, I guess, if you will. We're going to blur the line between industrial automation and commercial automation and home automation. You know, many of you might be into home automation, kind of like I am, and you may have an application, whether it's at your house, or maybe you've got a light commercial application where you're considering using some home automation products, but you'd like to keep some of the flexibility that you have when you're working with products like the Horner OCS. So we're going to go through a few different use cases, talk about how to use the OCS in, you know, maybe a different environment than an industrial one, and talk about how to use some of those wireless home sensors in some lighter commercial applications. So it should be a fun session. Okay, for those of you who haven't subscribed to our channel, don't hesitate to do so. It won't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so until next week, when we talk about home automation, let's all get out there and do us some good.